and today we're going to have a very good time balancing chemical equations. The thing you're learning today is something very important because it is the first thing you have to do when doing stoichiometric calculus. Even though it is something really important, it's very easy and mechanical, so come with me to master it. Let's go!
Binnacle project.
The first equation they are asking us to balance is hydrogen gas reacts with oxygen gas in order to form water. Okay? Easy, right? Let me use this first equation to introduce you to what a chemical equation is. It is a structure like this one. It is formed by some substances that appear on the left side in order to form substances that will appear on the right side. The substances at the left side are the so-called reagents, and substances on the right side are the so-called products. Of course, these substances are going to disappear in order to form the other ones. On this occasion, we have hydrogen gas, or molecular hydrogen. Let me draw it for you. It is formed by two hydrogen atoms. Here you have them, one and the other one. Reacting to oxygen gas, also called molecular oxygen, it is also formed by two oxygen atoms, one and the other one. In order to form water, which is formed by one oxygen atom, here you have it, bonded to two hydrogen atoms. Easy, right? And what's happening here? As you probably know, atoms cannot appear or disappear. On the left side, we have two hydrogen atoms, the same as on the right. But we have two oxygen atoms on the left and only one on the right. So what are we going to do? We are placing some numbers in these positions in order to balance, in order to adjust the number of atoms on both sides. So, well, we have two hydrogen atoms here, two on the right. But as we have two oxygen atoms on the left, why don't we place number 2 here, and 2 times 1 is already 2, the same as the oxygen atoms on the left. The oxygen atom is already balanced. But what happens with the number of hydrogen atoms? 2 times 2 is 4 hydrogen atoms on the right. Why don't we place here number 2, and now the hydrogen atoms is already balanced. As this is the first time we are balancing an equation together, let me draw the situation for you. Our calculus says that two hydrogen molecules, one, and let me draw the other one. Here you have it. React with one oxygen molecule in order to form two water molecules. One, and this is the other one. An oxygen atom bonded to two hydrogen atoms. And as you can see, everything's fine because we have 4 hydrogen atoms on the left and also 4 hydrogen atoms on the right. 2 oxygen atoms on the left and also 2 oxygen atoms on the right. The equation is balanced. Before going to the next one, let me tell you one thing. These numbers that we have already placed, the so-called stoichiometric coefficients, 2, 1, 2, can be read as molecules. 2 hydrogen molecules react with 1 oxygen molecule in order to form 2 water molecules, but also like moles. Don't forget it, moles. 2 moles of hydrogen gas react with 1 mole of oxygen gas in order to form 2 moles of water. Moles, not grams, please don't get confused with that. These are moles, but not grams. If you want to know how to convert from moles into grams and vice versa, please check out this video.
Binnacle project.
Having said that, let's do the other one. The second section says, nitrogen gas reacts with hydrogen gas in order to form ammonia. Easy, right? So let's begin. We have 2 nitrogen atoms on the left, and by placing here number 2, we already have 2 times 1 is 2. 2 nitrogen atoms on the right also. But as we have 6 hydrogen atoms on the right, by placing here number 3, 3 times 2 is already 6 hydrogen atoms on the left. That's it.
Binnacle project.
Let's go on with the next one. It says that hydrogen bromide reacts with iron in order to form iron 3 bromide and hydrogen gas. Okay? As you already know what's the game about, please stop the video if you want and try to do it by yourself. If not, please come with me. Let's begin with the hydrogen atoms. We have 1 on the left and 2 on the right side. So by placing here number 2, we will have already balanced the hydrogen atoms. Bromine. We have 2 bromine atoms on the left and 3 on the right. So what shall we put here in order to have also 2 bromine atoms on the right? This situation usually happens and it's very easy. As we want 2 bromine atoms, let's place here number 2 and let's divide it by 3 in order to cancel the effects of this little number. Don't forget it. As we need 2 bromine atoms on the right and this little number 3 is disturbing us, just place number 2 divided by 3. Of course that 2 times 3 is 6 and 6 divided by 3 is 2, just the number of bromine atoms that we need on the left side. Okay? And finally, as we have 2/3 iron atoms on the right, let's place here 2/3 and that's it. It's been a very interesting situation and it usually happens. Finally, if you don't want these denominators to appear, you can multiply all the stoichiometric coefficients by 3 and they will disappear. Look, let's multiply both sides by number 3. 2 times 3 is 6 hydrogen bromide plus 3 multiplying 2/3 is 2, isn't it? 2 atoms. And the same here. 3 multiplying 2/3 is only 2 molecules of iron 3 bromide. And 3 times 1 is 3. You can check it out and everything's correct.
Binnacle project.
So, the next one. It says that zinc sulfide reacts with oxygen gas in order to form zinc oxide and sulfur dioxide. Okay? As I told you previously, please stop the video and try to do it by yourself. Let me give you a little advice. It usually happens that when you are balancing an atom, perhaps when you are balancing another one, the previous one gets imbalanced. To avoid this situation, if you find any substance that is alone, as here the oxygen, okay, the oxygen is the unique substance that appears alone, leave it for last. Leave it for last. So let's begin, for example, with zinc. 1 zinc atom on the left, 1 zinc atom on the right. Sulfur. 1 sulfur atom on the left and sulfur atom on the right. And finally, the oxygen. 3 oxygen atoms on the right, and if you want 3 oxygen atoms here, let's place here number 3, and let's cancel the effects of this little 2 by dividing by 2. Can you see how easy it is? As on the previous one, if you want to make this denominator to disappear, just multiply all the stoichiometric coefficients by 2 and it will disappear. Look. 2 zinc sulfide reacting with 2 times 3/2 is 3. 3 oxygen gas in order to form 2 zinc oxide and also 2 sulfur dioxide. And the equation is already balanced.
Binnacle project.
The next one, and it says that copper 2 oxide reacting with copper 1 oxide and hydrogen gas in order to form solid copper and water. Let's do it. As I told you previously, I find here hydrogen alone and copper alone, so I will leave them for last. Let me begin with the oxygen. As we have 2 oxygen atoms on the left, by placing here number 2, we have already balanced the number of oxygen atoms. Now, hydrogen. 2 times 2 is 4 hydrogen atoms on the right, and by placing here number 2, we have already 4 hydrogen atoms on the left. And finally, copper. 1 plus 2 is 3 copper atoms on the left, and just by placing here number 3, we have already the copper already balanced.
Binnacle project.
The next one, it says that aluminum is reacting with hydrogen chloride in order to form aluminum chloride and water, no, hydrogen gas. I want to begin with the chlorine, as we have 3 chlorine atoms on the right, so by placing here 3, we have already 3 chlorine atoms on the left. Now hydrogen. We have 3 hydrogen atoms on the left, so by placing here 3 halves, we have already 3 hydrogen atoms on the right. And the last one is the aluminum. 1 aluminum on the left, on the right, so 1 aluminum on the left. And the equation is balanced.
Binnacle project.
And the next one, it says that calcium silicate is reacting with hydrogen fluoride in order to form silicon tetrafluoride, calcium difluoride, and water. It is very long, isn't it? But as you already know what's the game about, please stop the video and try to balance it by yourself. But let me introduce you to a very typical situation. Sometimes when you are trying to eyeball an equation, it's something really complicated because you begin to place several numbers in the different positions and it's impossible to do it. But thanks God that we have a mathematical method that will help us. Look, please don't be scared because it's very easy. We are placing these variables in these positions: A, B, C, D, E. And now we are adjusting the different atoms. Let's begin with calcium. Look. How many calcium atoms do we have on the left? A times 1 is A. Calcium, calcium, calcium here. D times 1 is D. Now it's turn for silicon. A times 1 is A. And C times 1 is C. Now it's turn for oxygen. A times 3, 3A, must be equal to E times 1, E. Look, can you see how easy it is? Now it's turn for hydrogen. B times 1 is B. And E times 2, 2E. And finally, fluorine. B times 1, B. must be equal to C times 4, 4C, plus D times 2, 2D. And here we have a system of 5 equations with 5 unknowns, and by solving it, we will have our equation balanced. Okay? What are we going to do to solve it? Look, it's very easy. Let's choose one of these equations. Typically, we choose the simplest one, the first one. Let's run it off. And we are choosing this information in order to rewrite the other 4 equations, which means whenever I find letter A, I will put letter D. D equals C. 3D must be equal to E. B equals to E, and B equals 4C plus 2D. And now we are doing the same. Let's choose the simplest one, of course, the first one. And I'm using this information in order to rewrite the other 3 equations. Whenever I find letter D, I will put letter C. 3C equals E. B equals 2E. B equals 4C plus 2D, 2C. Easy, right? Let's clean this system. It says that 3C equals E, B equals 2E, and B equals 6C. And we are doing the same. We are choosing the simplest one, for example, the second one, and we are going to use it to rewrite the other 2. 3C equals E, and B, 2E equals 6C. And let's reduce this equation by dividing both sides by 2. E equals 6 divided by 2, 3C. And wow, this is the same equation as the first one, so I'm not considering it, and this is the end of trip. What are we going to do now? Let's give some values. For example, let's say that C equals 1. C equals 1. E equals 3 times 1, 3. Let's go over here. D equals C, which means D equals 1 also. A equals D. A equals 1. And where is B? Here it is. B equals 2E. B equals 2 times 3, 6. B equals 6. And this is the solution of our equation. These are the stoichiometric coefficients. I'm just placing them on their positions, and A equals 1, there you have it. B equals 6. C equals 1, there you have it. D equals 1 also, and E equals 3. And you can check this equation out to see that everything is correct. Please don't be scared for the use of this mathematical method. It is very important for you to know how to adjust a chemical equation, and if you can't do it by eye, you should use this method that will lead you to the exit.
Binnacle project.
The penultimate, let's say it. It says that sodium carbonate reacts with hydrogen chloride in order to form sodium chloride, water, and carbon dioxide. Okay? So as it is a very long equation, let me use the mathematical method one more time in order for you to consolidate it. And of course, if you want to stop the video and try to eyeball it, please do it. But let me do it mathematically because I consider it's a bit complicated and I want you to consolidate this method. So A, B, C, D, and E also. How many sodium atoms do we have on the left side? 2A, that must be equal to C. Now, carbon atoms. A equals E. Now, oxygen atoms. 3A equals D plus 2E. D plus 2E. Now it's turn for hydrogen. B equals 2D. And finally, chlorine. B must be equal to C. Okay? And the same situation as in the previous section, we have 5 equations with 5 unknowns. And by solving this system, we will have our equation adjusted. Let's choose the simplest one, the second one, I think. And I'm using this information to rewrite the other 4 equations. 2E equals C. 3E equals D plus 2E. B must be equal to 2D. And finally, B must be equal to C. Right? Let's go on. Let me clean this equation because it says that 2E equals C and 3E minus 2E, 3E minus 2E is E equals D. B equals 2D and B equals C. Even though you may think that this is a very long method, it is not at all, because when you mechanize it, you can do it very fast. So please practice it a lot. Let's choose the simplest one. For example, the second equation. And we are rewriting the other 3 using this information. 2D equals C. B equals 2D and B equals C. Let's go on. Let's choose the third equation, that is the simplest one. And let's do 2D equals C and C equals 2D, which is the same equation as this one. So I'm not considering it. And this is the end of trip. Now it's time to give values to any of these variables. So let's say that D equals 1. So C equals 2 times 1, 2. Here B equals C, that is B equals 2 also. E equals D, that is E equals 1. And finally, A equals E, that is A equals 1 also. And these are the stoichiometric coefficients. Let me place them on their positions. A equals 1, there you have it. B equals 2, here it is. C equals 2 also, there you have it. D equals 1, and E equals 1. And as you can see, the equation is already balanced.
Binnacle project.
And now let's do the last one. I brought this equation to you because it's very interesting, as we are not given the substances but only words. Propane combustion. So what do we have to do? I'm afraid that you have to memorize typical equations, chemical equations, that you have to know how to build them up. Look, propane. The first thing you have to know is the propane formula, which is C3H8. Okay? This is propane. And when they're saying that combustion, it means that we are adding oxygen gas in order to produce water and CO2, carbon dioxide, okay? And I'm afraid that you have to memorize these terms. Having said that, let's balance it as you already know. You can stop the video and try to eyeball it. 3 carbon atoms, so let's place here number 3, and we have already the carbon atoms balanced. What do we have over there? 8 hydrogen atoms, so by placing here 4, we will have already the hydrogen atoms already balanced. And finally, oxygens, 4 plus 6, 3 times 2, 6. 10 oxygen atoms on the right, so by placing here number 5, we have already the oxygen atoms balanced, and thus the entire equation. And now, access the full video from which this clip is taken, or move on to the next video. And of course, hit like, turn on notifications, and leave a comment. See you soon!